A very good afternoon to everyone. So, I welcome you all in this lecture of revision series in which today we are going to discuss about work, power, and energy. Okay, so this is the continuation of our revision series. We have picked some most important concept and most important questions also. So, we will see them one by one. Okay, it will definitely help you out. Give me a sec. Okay, so let's just get started with it. Now, today we are going to learn about the work done, or I must say that today we are going to revise about the work done, kinetic energy, conservative and non-conservative forces, potential energy, work energy theorem, and power. And also, we are going to see some PYQs, important questions, and the concept behind them. Okay, so it's going to be a very interesting yet very conceptual lecture. So try to be attentive in this. Now let's get started. So if I talk about the work done by constant force, because if I talk about the specifically work done, so work is done by two types of forces. First by constant force, when the force applied is constant, and when the force applied is variable. So it is a variable kind of force. In both the cases, work has to be done. The definition of work is nothing but the force that we applied to displace a system from its initial position to some final position. The dot product of that force applied with the displacement is termed out to be as work done. Okay, so basically you can say that work is nothing but the effect of force to displacing that particle. Okay, because bina force ke, without any force you can't displace anything. Okay, so by the definition of work done, it is nothing but F vector dot D vector, where F is the force and D here is the displacement. Okay, displacement itself is a vector quantity and it is the minimum distance between 2 points, and that point should be final and initial, where we have started the motion and where we have finished the motion. The minimum distance between those points is turned out to be the displacement. It is the displacement. Okay, so work done we have as force vector dot product with D vector. D is nothing but displacement. Now if we open this expression, the work done here is FD cos of theta. This is the way when a dot product open. So F and D is now the magnitude, and cos theta is the angle between force vector and displacement vector. For example, if this is a block and we have applied a force making an angle theta with this, and this force displaces this object with a distance s, and here now the force is F, the angle is theta. So we can resolve this force in two component, F cos theta and F sine theta. Now, the work done you will see here is equals to F of cos theta into D, which means you have to take the component of force which is along the displacement, along the displacement. So it is a very important point. Try to remember it. Keep this point in your mind that we have to take the component of force which is in the direction of displacement. Okay, got it. So this is when the force is constant. When force is constant. So you can apply this expression directly, that work done is FD cos of theta. Okay. So this is about the work done by a constant force. Now moving in the aggression of it, we will solve a question based on the concept that we have learned. So here a small particle moves to position 5 I cap minus 2j cap plus k cap from its initial position 2 I cap plus 3j cap minus 4k cap under the action of force 5 I cap plus 2j cap plus 7k cap. Here all the things are mentioned in the vector form. The value of work done will be. So if all the data like displacement and force is given you in terms of force, in terms of vectors. So use this expression. Which expression we are going to use in this? The work done here is F dot D. Okay. Now you can check one thing also. Here the force is a constant quantity because it is 5 I cap, which is a constant number. 2j cap, it's also a constant thing, and 7k cap, it's also a constant thing. So this force is not variable. Okay. Now F dot D, displacement you have to find out. Displacement is D final, you can say it, D final vector minus D initial vector. These are the position vector of final position and initial position which is given to you. The particle moves from this position. This is the initial position and this is the final position. Now put this value directly into it. So the final vector is 2 I cap 3j cap minus 4k cap minus initial vector is 5 I cap minus 2j cap plus k cap. Now, if you subtract it, multiply this expression with a minus sign, so it will become minus 5 I cap plus 2 I cap. So it will become 3 I cap minus 3j cap, minus into minus plus 2j cap will become plus 5j cap, minus 4k cap minus k cap will become minus 5k cap. So this is the final displacement vector you have. Now all you have to do is just take the dot product of it. Force vector is given to you as 5 I cap plus 2j cap plus 7k cap. Dot product with minus 3 I cap plus 5j cap minus 5k cap. Now, you know the rule of dot product. These I, j, k, n are the unit vectors. So we know that I dot I cap dot I cap equals to 1, I cap dot j cap equals to 0, I cap dot k cap is equals to 0, and this is same followed by the another vectors, another unit vector. If you talk about j, so j cap dot j cap is also 1, and rest of the other, if you multiply j with k and j with I, so it will result in 0. Same thing will be followed by k cap. Okay. So here this, you look at this expression, 5 I cap multiply with minus 3 I cap. So 5 into minus 3 will become minus 15. I cap dot I cap will become 1. Okay. So in this, I will directly tell you a short trick. Do not multiply the whole expression with 5 I cap and 2 j cap and 7 k cap. Try to multiply only the I component, j and j component, k and k component. Okay. So 5 I cap with minus 3, I cap will become minus 15. 2 j cap plus 5 j cap will become plus 10. J cap dot j cap will become 1. 7k cap minus 5k cap. 7 into 5 will become minus 35. K cap dot k cap will become 1. So it is 15 minus 15 minus 35 will become 50. So minus 50 plus 10 is equals to minus 40 joule. So this is the work done that we have. Okay, so it will be minus 40 joule work that we have did. Got it? Now, so we have taken only the positive symbols. So answer will be 40. Now work done by a variable force. So simple. Look, if the force is vary with distance, like this, so this is kind of variable force, you can say. This is kind of variable force. Okay, because as the distance increases, the value of force also increasing. So what we will do that we will take a very small displacement. Here I have taken it a little bit to make you understand, but it is very small. And the length of this strip or the displacement is dx. So what is the concept? If you will see this curve here, it seems to you a little tilted, which means it is increasing. But if you decrease this, the width of this strip, as you decreases, it will seems you as a constant line. So we can say that, hello Swati, how are you? Good afternoon. So here we are discussing with work done by variable force. So in this expression, this work, or we can say this force, is a variable force because it is varying with respect to the distance. You can say it as the distance increases, the force will also increasing. Okay, the force is also increasing. As the distance increasing, force is also increasing. So this is a variable force which is vary with respect to the distance. Here I have taken this force is dependent on the distance. Okay, so what we will do, we will consider a very small strip of length dx. Here it seems to be a big strip, but it is a very small strip. So for that particular displacement, this line of force, which seems to you a variable line, but if you decreases that width of this strip, this will seems to you as a constant line. So we can say that for a very, very, very small displacement, this variable force will become a constant force. So concept here is, so for very, very small displacement, variable force act as a constant force. Okay, so we can say that in displacing any object or any system to this small displacement dx, the work done will also be very small. So we can say that dw here is f dot dx. Now we can calculate f dot dx basis on that, because force here we have considered a constant force. for a very small displacement. Now, if you integrate it with a proper limit, you will get to know the total work done by this force. Okay. Hello, Dhanushri. How are you? Good afternoon. So work done here we can take is the integral of this small work done, the displacing the particle with this small displacement and adding them. Okay. One thing to note here, if you will take, if you will see that this is the variation, this is the variation of this force with respect to distance, and the strip we have considered here is dx. So this f dx is nothing but, if you consider it a rectangle, this length, this height here is f, and this distance here is dx. So if you calculate the area of this strip, it is nothing but f dot dx. And if you able to calculate the complete area, the total area, so you will get to know the total work done. So we can also say that work done is also equals to the area under fs curve, and fs curve is nothing but the force displacement curve. So many times in JEE, the question has been asked, the graph is given to you, f of x, and it has been asked the total work done. So what do you need to do? You will just have to calculate the area under the force, under the graph given to you. Okay. And this is the value of total work done. Now, based on the previous concept, we have a question here. So try to solve this question. A force F vector is equals to 2 plus 3x I cap act on a particle in the x direction, where F is in the Newton and x is in the meter. So the work done by this force during a displacement of x is equals to 0 to x is equals to 4. Very simple. Although I have also taught you the sufficient concept to solve this. So try to solve this. F vector is given to you as 2 plus 3x I cap. Okay. And it acts on a particle in the x direction, where F is in Newton and x is in meter. So the work done by this force during a displacement from x is equals to 0 to x is equals to 4. Now you can see here, this force is a variable force because it is dependent on x. Got it? So we need to calculate small work done, which is nothing but f dot dx. Now, displacement is also taking place in x direction. So dx I can write as dx I cap. It is the displacement vector, because displacement is taking place in x direction. So for small displacement, the vector will be dx I cap, because I cap is the unit vector of x direction. So I will put the value here. F vector is 2 plus 3x I cap dot dx I cap. Now I cap and I cap will become 1. So it is 2 plus 3x dx dw. Now the total work done we have to calculate from x is equals to 0 to x is equals to 4. So work done here will be equals to integral of 2 dx 0 to 4. We have multiplied dx here, plus 3x dx. Now calculate the value. Work done here is 2 into x 0 to 4 plus 3 into x square by 2 0 to 4. Now 2 into 4 plus 3 by 2 x square, put the value 4 square minus 0 square, we will not consider that, it will become 0, and integration of x dx has a formula x square by 2. So 2 4 ja 8, 3 by 2 into 16 will become 8. So 8 plus 24 will become 36. So any kind of doubt? A very simple kind of question is this. Okay. So this is the answer of this question. Now, just a second. 8 plus 24 will become 32. Okay. Now, kinetic energy. So kinetic energy, it is come, it comes because of motion of any system. कोई भी system, if any system is in motion, it must acquire a kinetic energy. Okay. Kinetic energy is given by 1 by 2 times mv square. This is the formula for kinetic energy. It is a scalar quantity. Scalar quantity means you don't need to worry about the direction. Okay. So this is kinetic energy. Now, kinetic energy you can also write as, because we know that P, which is momentum, is equals to mass into velocity. Okay, I am taking the magnitude here. So it is m into v. Now, v is equals to p upon m. Put the value here. So it will become 1 by 2 times m into p square by m square. Now, one power will be cancelled out. So it will become p square over 2m. This is the kinetic energy. Now, kinetic energy in this term, if you will see, so one can conclude that momentum is a vector quantity. So how can we relate a vector quantity with this scalar? Because you have told us that kinetic energy is a scalar quantity. So here we have taken only the magnitude. It is the magnitude of momentum. Okay. Got it? So there is a very famous question. If I ask you, if there is a particle which is moving in this direction, and after some time it will moving in this direction, it has changed its direction. So you will tell me, would the kinetic energy will change and momentum? So what will be changed? Kinetic energy or momentum? Now, because from here you can say if momentum is changed, has been changed, so kinetic energy would definitely be changed. Okay. But here in this example, if you will see, if this has a velocity v which remains constant, okay, the magnitude of this velocity is constant, which means speed is constant, and this has a turn here, a sharp turn. So there is no change in magnitude, but there is the change in direction. So if direction is changing, which means velocity is changing, because velocity is a combined effect of direction and magnitude. And this p is a vector quantity which depends on the velocity. So momentum will change here, but Kinetic energy will not change because kinetic energy will only depend on the magnitude of velocity. The speed is constant, which is the magnitude of velocity. So we can say that kinetic energy is a constant quantity. Got it? Now you must have a doubt that where this expression has come. Okay. So we will say that the work done by any force is F dot ds. Work done from Newton's second law is nothing but mass into acceleration. It is ds. Now m, acceleration is dv by dt into ds. You can combine this ds and by dt. So it will become mv square, sorry, mv dv. If you integrate this expression, so you will have m into 1 by 2 times v square. So it is half m v square. So it is nothing but the work done. Okay. From here the expression has come. Because body has acquired motion or acceleration because of the force. So this is the energy because of the motion of any object. So two formula you must remember, half mv square and p square by 2m. Here p is the magnitude only. This is the magnitude. Now, this question, a body is dropped on the ground from a height h1 and after hitting the ground, it rebounds to a height h2. This is the body. It has been dropped from a height h1 and then it rebound. After striking the ground, it rebounds up to a height h2. Okay. So if the ratio of velocities of the body just before and after hitting the ground, means here is the velocity v equals v1 when it is not hit the ground. Just before hitting the ground, it has a velocity v1, and after hitting the ground, it has a velocity v2. The ratio is given to you as v1 by v2 is equals to 4. Now the percentage loss in kinetic energy of the body is x by 4, which means k final minus k initial divided by k initial. This is how we are going to calculate the loss. And if it is given in percentage, so we will have to multiply it by 100 equals to x by 4. It is given to you. Now the value of x you have to find out. So it is very simple question. Do not confuse with this height and all. Try to apply the simple concept. Now, whenever the loss, what we have to do? We have to subtract the final value to the initial value. Okay. So here we can say that the loss in the change in kinetic energy, which is the loss automatically, it is the kinetic energy final minus kinetic energy initial. Now, if you talk about the final kinetic energy, it is 1 by 2 times mv2 square, because the final velocity is v2, minus 1 by 2 times mv1 square. It is k final minus k initial. Got it? Now k final minus k initial, you know the value of v1 by v2, to try to make it this. Okay. And remember this expression also. Now we have got the value of k final minus k initial. Only k initial we need. We can make k initial by, if I take this as a common, so 1 by 2 mv1 square is equals to, so 1 by 2m I have taken common, v1 square is also common, so it will become v2 by v1 whole square minus 1. This is nothing but k final. So k final minus k initial divided by k final, sorry, k initial, because half v1 square will become k initial. We divided by k final, we divide K final minus K initial by this expression, or we will take it into the denominator of it, equals to, now we know the value of V1 by V2. So V2 by V1 will be the reverse of it. So it will become 1 by 4 whole square minus 1. So K final minus K initial, if you multiply this expression, K final minus K initial divided by K initial multiply by 100, so it give you X by 4. It is the percentage change or loss in the kinetic energy, and it is given you as X by 4, and it also equals to 1 by 4 square minus 1. This will result in 15 by 16. Okay, so you need to multiply it by 100 also, because we have multiplied 100 here. So 4 4 just 16, and if you multiply it with 25, it will give you X is equals to 275. So this is the value of X. Look how simple this is. If you go according to the concept, you know the percentage change formula here. Okay, and the correct interpretation or correct extraction from the question you have made, V1 by V2. We apply the formula, apply the logic, and get the answer. If anyone has any kind of doubt, they can ask. Okay. So it is not 275, it is 375 if you multiply it. Okay. Now, look at this question. A lift of mass 500 kg is descending with a speed of 2 meter per second. Its supporting cable begin to slip, thus allowing it to fall with a constant acceleration of 2 meter per second square. Now, the kinetic energy of the lift at the end of the fall through a distance of 6 meter will be. Okay. So we can say that what is given to us? The given data here is the mass of lift, which is 500 kg. And it is descending initially with a velocity of 2 meter per second. Okay. And now the supporting cable begin to slip. So it is falling with a constant acceleration of 2 meter per second square. Now, kinetic energy of the lift at the end of fall through a distance of 6 meter will be. So what we are going to do, there is nothing much required in this question. Time is given to you, sorry, distance is given to you 6 meter. 6 meter के लिए it is descending with an acceleration of 2 meter per second square. Okay, so we can say that the final velocity will become V final is equals to V initial. We know the formula from equation of motion. V square is equals to U square plus 2AS. Now it is accelerating, which means acceleration is also acting in the direction of displacement or in the direction of velocity. So V final you will have V final square, you will have U square. U square is given to you as 2, 2 square will 4, multiply with 2 into 6. Because acceleration is given to you as 2 meter per second square. So it will become 4 plus 2 to the 4, 4 6 the 24. Okay. So it will give you 28. Got it? This is 4. So final velocity that you have is square root of, just a second, square root of 28 meter per second. Okay. Now, we want to know the final kinetic energy. So final kinetic energy will be 1 by 2 m V final square. Simple. So 1 by 2 m is 500 kg multiplied V final square, which is square root of 28. So it will 14. Okay. So now you will multiply it. It will give you 14 into 500. So this will result in 70 and double zero also. So it will give you 7 kilojoule of final kinetic energy. Any kind of doubt in this question? Anyone? Any kind of doubt you have, you can ask. Okay. So try to note this question. Try to note down this. You can check this. This is 7. Actually, it is given to you 7 because 7,000 joule will become 7 kilojoule. And answer has been asked in kilojoule, so it is 7 kilojoule. Now, if I talk about the conservative forces, so conservative force are those forces, I will write work done in a complete cycle equals to 0. That force is termed as conservative force. Conservative force. So if the work done by any force in completing a cycle is 0, then you can say that force is a conservative force. Now, how to identify the conservative force? So first is all constant force. Constant force are conservative. Any type of constant force, 2 Newton, 3 Newton, 3 I cap plus 4 J cap Newton, these all are the examples of conservative force. And second, if in terms of variable force, F is given to you as F of x I cap plus F of y j cap. Here, if fx is only the function of x and fy is the only function of y, which means there is no y in this fx and there is no x in this fy. So that type of force also you can say that it is a conservative force. It is also a conservative force. For example, F is equals to x I cap plus y j cap. So here the function of x is only x and y is y. Another example you can take x square plus 2x I cap, y square plus 5y j cap, and also in terms of z square plus 3z k cap. So this you will see, you will check this fx is the only function of x, fy is the only function of y, and fz is only function of z. Okay. And in third situation, if f dot ds is a perfect differential. Then also you can say that force here is conservative. Okay. Now, non-conservative force, and if I talk about the examples of it, the gravitational force, spring force, and you can say, yeah, gravitational force and spring force for now, and also the electrostatic force. So these all are the examples of conservative force. Now, non-conservative force, if the work done is not zero, work done is not zero in a cycle. Cycle, you understand na? This way, which means initial position is equals to final position. So if in this the work done is not zero, then force we can say here is non-conservative, which means there will be a loss. Okay, loss of energy. Conservative. In daily life, we will deal with these forces, non-conservative force. So non-conservative force are the normal force, or you can say the frictional force. Frictional force. Okay. So these forces are responsible for the loss in energy. Responsible for loss in energy. We cannot apply, we cannot apply the energy conservation when these forces are in application. Energy conservation for non-conservative force. So for these forces, we cannot apply the law of conservation of mechanical energy or conservation of energy, because in this the energy initial will not be equals to energy final. So there will be a loss in energy, either in terms of potential or in terms of kinetic energy. Now, potential energy. So potential energy is associated with conservative force. Conservative force. So if there is a conservative force in action, there will be a potential energy associated with it. Okay, because the work done by this conservative force will directly or indirectly store in the form of potential energy of the system. And what is that? It is the energy, it is the energy of a system because of its arrangement. How the system has to be arranged, it has been arranged, or configuration. Okay, so we must draw a reference line. Reference, or we must take a reference value for exact value of potential energy at any point, at any given point. Okay, so there are different types of potential energy. I will cover them rapidly. It is gravitational. Just a second. It is gravitational potential energy, which is given by mgh, okay, or minus of g m1 m2 upon r. So you will use this expression most in the chapter work, energy and power, and this will be utilized in gravitation. Then we have a elastic potential energy, or we will say it as spring potential energy. You can say spring potential energy or elastic potential energy. We will have it value as 1 by 2 times kx square, where k is the spring constant, x is the displacement of the spring. And we have a electrostatic potential energy, which is have no use in this chapter because no question has been asked including electrostatic potential energy in work, energy and power chapter. Okay, although you can learn the expression u is equals to minus 1 upon 4 pi epsilon naught q1 q2 upon r, where r is the distance between these charges. Say r is the distance here between two mass particle m1 and m2. Okay, now here a 0.4 kg mass takes 8 seconds to reach ground when dropped from a certain height p above surface of earth. The loss of potential energy in the last second of fall is last second mein, which means if I have an object, I have dropped it. So here is the distance covered, and here is the distance covered in the last second. So we are interested in this value of kinetic potential energy. So what we are going to do, we are calculating this distance s, okay, and calculate the value of height and apply the formula u is equals to mgh, because there is only this force is acting, only mg force is acting in downward direction. So mgh we are going to apply, but before that we have to find out that how much distance is it will cover, not in 8 seconds, in 7 seconds. Okay, so because 8 seconds it takes reach to the ground, so in last second, which means which is from 7 to 8, it has been asked what is the potential energy, loss of potential energy in the last second. So what we are going to do, we are calculating it for complete height, then for 7 and subtract it. So we will get potential energy for 8 seconds minus potential energy for 7 seconds. So we will get potential energy for loss for 1 second. So for that, we need to find out the height in 7 seconds and 8 seconds. So it's a very simple question. Mass is given to you as 0.4 kg. Okay. Total time of flight is given to you as 8 seconds. Now, if a body is dropped means initial velocity is 0 and it cover a distance h, in time t. So what is the relation between t and h? So it is directly given as t is equals to root 2h upon g. So try to remember these formula with the context where this formula has to be applied. Okay, so it will going to save a lot of time of yours. So t equals to here is root 2h upon g. So we will take it for 8 seconds. For 8 seconds, take the square root here. So it will become 8 square. 2 into h divided by 10. So it will become 64 into 10 divided by 2 is h in 8 seconds. So h8 will become 2 3 is 6, 2 2 is 8, 320 meter. Now in 7 seconds, same formula will be applicable. So it will become 7 into 7 multiply by 10 divided by 2 h in 7. Okay. So this will become 5. If you apply it 7 7 ja 49 multiply with 5 7. 5 9 ja 45. 4 is the carryover. 5 4 ja 20. So it will become 24 meter. So height in 7 seconds will become 240. So in 1 second, what is the height covered? So you can subtract it. It will become h8 minus h7. So 320 minus 245. It will become 5. It will become 1. 11 minus 4 will become 7. Okay. So 75, I think it is the answer for height covered. Now the potential energy will be mgh. What is the mass? 0.4. What is gravity? 10. And what is the distance covered? It is 75 meter. So multiply this. So it will become 75 into 4. 4 5s are 50. Sorry, 4 5s are 20. So carry over is 2. 4 7s are 28. 28 plus 2 will become 300 joule. Answer is 300. Got it? Any kind of doubt you can ask. Now work energy theorem. Work energy theorem is very simple. The work done, net work done is given by change in kinetic energy. This is all about the work energy theorem. Although if the change in kinetic energy is variable, so we can, if the force acting is variable, so we can apply it for small changes dk. This is the another expression. We can say that kinetic energy depends on frame of reference also. Frame of reference. If the frame of reference change, kinetic energy will become something different from the initial one. Now, I will discuss the concept first that I have here is power. So power, if you talk about power, is the rate of doing work. The rate of doing work is called power. Rate means we are doing work with respect to time. Rate of doing work per unit time, which means we are measuring work with respect to time, that how much work we have done in this particular time period. The ratio of that will give you power. So P is equals to delta W, which is the work done in delta T times. So if this is the total work divided by total time, it will give you the average power. So average power. Okay. But if you are interested in the instantaneous value, So the power will become dw by dt for a particular instant. So it will give you the instantaneous power. Instantaneous power. Okay. And one of the most famous expression of power is P is equals to d by dt of w. W is nothing but F dot ds. So it will become F ds by dt will become what? ds by dt will become velocity. So P also we can say that it is force multiplied with velocity. So if this is the force acting, and let's say this is the angle theta, so we can say that this F cos theta, which is in the direction of velocity, is going to have the power or change the power. Okay. So power is also F cos theta into V. So you have to take the component, tangential component of force. Okay. So this is it. The rest of the question we will see in the next lecture. Concept wise we have done. Okay. In any, if any kind of doubt you have, any expression, I will repeat it for you. But for now, the lecture has been over. If you have any kind of doubt, you can ask. Otherwise, the lecture will be over. And thank you so much for being attentive. And please try to be on time so that you will get more and more. Okay. So please try to be on time. Thank you for your time for me. Have a good day. Bye-bye.